So today we're going to learn the process of preparing solutions in the lab. We'll get to do this hopefully in the lab pretty soon. To prepare a solution, the main piece of equipment you need is called a volumetric flask. This is what a volumetric flask looks like over here. It's really useful for measuring super precise volumes. So each volumetric flask has a different volume it might measure. Maybe there's a 200 milliliter one or a 500 milliliter one, and you choose the right volumetric flask for the solution that you're mixing up. So the steps that we'll follow when we get to the lab are this. First, we're going to measure the right mass of solute on a balance. So we'll use a weighing boat and really precisely try and get just the exact mass of solute that we need. Then we dissolve that solute in water inside our volumetric flask. So we add a bit of water to the bottom of the flask, then add our solute, and then we need to fill this up with more water. So for the big bulb of the flask, there's lots of water goes in there. You don't have to be precise about the large bulb of the volumetric flask. So here you're going to just take a beaker and pour the water in until it gets to the top of the neck, right about here. So you can go to there with a beaker. But then you're going to be filling up the neck with water. And what you're looking for is there's a little line right here on your volumetric flask. And that line will indicate for this volumetric flask 200 milliliters, or whatever the volume is of that specific volumetric flask. So you're trying to get right to that line on the volumetric flask, and you've got to do it really precisely. So to measure, to add quantities of water more precisely, we're going to use a plastic pipette. So this is a plastic pipette right here. That's what one looks like. So we'll just be adding little drops of water into our volumetric flask until it fills up to that line. What we're looking for is the specific moment when the bottom of the meniscus of water is at that line. So the meniscus of water, you know how, I'll just do a really zoomed in picture. So this is the neck of your volumetric flask. And here's that line that we're going for. The meniscus is that the way water makes like a little scoopy thing like this in a narrow tube. And that's because water feels some adhesion to the sides of the tube and it makes it creep up the sides. So that's the meniscus. We're looking for when the bottom of that meniscus is right at the line. So the water should look like this in the tube, just the bottom of the meniscus right at the line where you're at 200 milliliters or whatever the volume is for the flask that you're using. Then we're going to check and make sure the stopper is not too small for the flask. We have to make sure we use the right one. If your stopper goes in and gets stuck, you can't get them out. So really important that you use the right size stopper. You'll put a stopper in the top of your flask and then you're going to invert it. So that means you'll hold the stopper on with one hand and then turn it upside down, flip it over, turn it upside down. You're going to do that at least 25 times. So that ensures really thorough mixing so that all of that solute is super nicely dissolved. Then you store it in a labeled container so that you know what you've got. And that's the whole process that we're going to use to prepare a solution in the lab. Now, what if you went too far, right? Like you're aiming for this very precise moment when the bottom of the meniscus is right at the line on the volumetric flask. So what if maybe you don't use the plastic pipette? Maybe you pour some in with a beaker and you just overfill it and so you go up to here. Can you just maybe take the plastic pipette in and suck a little bit of water out? No, you cannot, right? Because you've now mixed it with the solute. You'll totally change the concentration if you take any water out, because that water has solute dissolved in it. It's not just pure water in the neck of your volumetric flask. So if you add too much water and you go past the line, what have you got to do? You have to safely dispose of it and start over. So safely dispose of your solution and start the whole process over. That's really the only solution for that. All right, we'll do a tiny bit of math with how we prepare solutions. So often what we'll do once you've prepared your first solution, so you might create what's called a stock solution, or you might order a stock solution for your lab from a science store, and then you need to dilute it to the concentration that you need. So we do this a lot at our school, right? We'll order a super concentrated version of many of the solutions that we use, and then we'll dilute them down to something that's safe to use in the lab for you. But let's do an example that you've probably done before, which is making orange juice. Is essentially diluting a stock solution. So when you make orange juice, you start with orange concentrate, and the concentration of the orange concentrate is 0.34 molar, let's say. So that's the initial concentration. So I'm going to call that C1. The initial volume of those little orange concentrate containers is 250 milliliters. Now for these problems, you can be in liters or milliliters as long as you're consistent on both sides of your equation. But because of the fact that I'm using molar concentrations, and I've really emphasized the importance of being in liters for most molar concentration problems, I'm going to switch this to liters just to be kind of consistent and safe with that. So that's the volume we start with. That's the volume of your orange concentrate, and the concentration is 0.34 molar. Where we want to end up, it says how much water do I need to add to make it 0.1 molar orange juice. So the concentration that I want here is 0.1 molar. That's where I'm trying to get to. That's my C2, and that would make the delicious orange juice for me to drink. But how do I get there? What volume will that final thing need to be? And how much water do I need to add to get to that final volume? There's a really handy equation here. So this is a new equation for you. So make sure you write this down. And that is this one. C1 V1 is equal to C2 V2. Or in other words, your initial concentration, C1, multiplied by your initial volume is equal to your final concentration, C2, multiplied by your final volume, V2. Super handy equation whenever you're diluting something. So that's the equation that we're going to use here. Just a few notes here. V2 is not the amount of water you add. V2 is the final volume. And V1 is the initial volume. And this is of the entire solution that you start with. C1 is that initial concentration. And C2 is the final concentration that you're aiming for when you're diluting your solution. All right, so we know C1, V1, and C2. We can totally rearrange this for V2. I'll do that over here. So C1 times V1 will equal C2 times V2. To rearrange this for the final volume, you just have to divide both sides by the final concentration. That cancels C2 on this side, and I'm left with V2 is C1 V1 divided by C2. All right. Let's plug our numbers into that. So V2 is going to be C1, 0.34 molar, multiplied by V1, 0.25 liters, divided by C2, 0.1 molar, and we'll toss that all into our calculator. So 0.34 times 0.25 divided by 0.1, that gives me 0.85. So my final volume is going to be 0.85 liters. Now, if I look at significant figures here, I'm actually not given very much. I'm actually only given one sig fig, so I'll have to round that V2 off to 0.9 if that volume was what I was finding at the end of the day. But it's actually not my final result that I'm going for here. What I'm asked to find is how much water would I need to add to reach that concentration. So my final volume of my solution is 0.85 liters. The initial volume, the V1 where I started, was 0.25 liters. So how much water do I need to add to my initial solution in order to dilute it down to a V2 of 0.85 liters? What I would have to do is just subtract those volumes. So the volume of the water added is going to be your final volume V2 minus your initial volume V1. So it'll be that 0.85 minus the 0.25. So 0.85 liters minus 0.25, that gives me 0.6 liters. So that's the amount of water that I have to add to my initial solution in order to dilute it down to that final volume of 0.85 liters. Now, this whole process can actually work with the percentage concentrations too. So it works great with molar concentrations, but it works with any form of concentration. Even parts per million, you could do it with that too. So say you want to do percent V over V or percent M over V, you can use the same process. What you do is you take the percent, the initial percent, whether that's a mass percent or a volume percent, multiplied by the initial volume, and that will equal the final percent, percent 2, multiplied by the final volume. So it's exactly the same formula, just with percentage concentrations instead of molar concentrations. Do a little example here. We want to know what volume of water do I have to add to 120 milliliters of solution that is at an initial concentration of 30.5% grams per milliliter, and I want to get that down to a concentration of 26% grams per milliliter. So start with writing down what you know. So my percent M over V is 30.5% grams per milliliter. That's the initial one. The one I'm reaching, the final percentage that I'm reaching, so percent M over V2 is 26% grams per milliliter. And the initial volume, right, so the volume of the initial solution, V1, is 120 milliliters. Now, usually when we work with percents, we do stay in milliliters, and so here we'll stay in milliliters. In all of these dilution problems, as long as you have the same units for the volume on the left side as the volume on the right side, it will actually always work out. I just like to stay in the units that you're using for your concentrations as well. So my V1 is 120 milliliters, and what I want to find is how much water do I have to add? But to get there, first I'm going to need to find V2. So I use the same formula as before, but with percentages. So percent 1 times V1 is equal to percent 2 times V2. We're going to rearrange for V2, so divide both sides by percent 2. That cancels the percentage on this side. And then we'll plug in our numbers. So I have V2 is equal to percent 1 times V1 over percent 2. Percent 1 is the concentration you start at, 30.5%. V1 is 120 milliliters. Percent 2 is the concentration I end with, which is 26%. So my V2 will be, plug that all in, 30.5 times 120 divided by 26. Gives me 140.8 milliliters. Now my next step is to find the actual volume of water added. So if I start with a volume of 120 milliliters and I need a V2, a final volume of 140 milliliters, then how much water do I need to add? Well, it would be the subtraction of those. So the volume of the water added will be V2 minus V1. How much new water do I have to add on top of V1 to reach V2? And that looks like it'll be 20.8 milliliters. I'll check my significant figures. It looks like 2 sig figs is the way to go. So let's round this off to 21 milliliters for the volume of water added. There you go.